Once again, Achievers Consult, where science is made easy. In our last class, we were able to establish the relationship between velocity ratio, mechanical advantage, and efficiency. And we said these three parameters are common to every type of machine. We have also looked at the pulley system, and we said the number of pulleys is equal to the number of velocity ratio. If you have 5 pulleys, that means the velocity ratio of the pulley is 5. If you have 6 pulleys, that means the velocity ratio of the pulley is 6. Today we'll be moving ahead on the machines to look at the wheel and axle. The type of machine we are studying today is the wheel and axle. The wheel and axle is a simple machine used to raise water or sand from a very deep hole or pit. For a wheel of radius r and axle of radius small letter r, it follows that work input, work done by effort, that means work input is work done by effort, is equals to work output, work done by load. That means work input is equal to work output. Effort, work done by effort, is equals to work done by load. Effort times distance moved by effort is equals to load times distance moved by load. Effort times circumference of wheel is equals to load times circumference of axle. Therefore, velocity ratio, effort equals circumference of wheel. Effort times circumference of wheel equals load times circumference of axle. The small letter R represents axle, while the big letter arrow represents the wheel. The big letter arrow stands for the radius of the wheel, while the small letter arrow stands for the radius of the axle. So effort times circumference of the wheel equals to load times circumference of the axle. Therefore, velocity ratio equals distance moved by effort over distance moved by load. Velocity ratio is also equals to circumference of wheel over circumference of axle, which is equals to radius of wheel over radius of axle. For a frictionless wheel and axle, mechanical advantage is equals to velocity ratio, and we know that velocity ratio is also equals to radius of wheel over radius of axle. Efficiency of wheel and axle is equals to work output over work input times 100%. Load times circumference of axle over effort times circumference of wheel times 100%. That's efficiency. Efficiency is also load over effort, from here, load over effort times radius of axle over radius of wheel. From here, we are also getting this. That means you cannot use this to calculate for efficiency. You use this formula to calculate for efficiency, or you use this formula to calculate for efficiency. Work output over work input times 100% based on what you are giving in the question. The parameters you are giving the question determines the formula you are going to use. Work output over work input times 100%. Efficiency is also load times circumference of axle over effort times circumference of wheel times 100%. Efficiency is also load over effort times radius of axle over radius of wheel times 100%. So whichever formula that is applicable is determined by the parameters in the question. Now let's look at question 1. A wheel and axle is used. This is jam question, but I think I didn't write that. This this jam question. Question 1. A wheel and axle is used to raise a load of 500 Newton by the application of an effort of 250 Newton. If the radii of the wheel and the axle are 0.4 centimeter and 0.1 centimeter respectively, the efficiency of the machine is, that means what is the efficiency of the machine? You are asked to calculate efficiency. So the first step, you list your parameters. By the time you list your parameters, you now know the formula that will apply. From these 3 formulas we have, you now determine the one that will apply. First step, you list your parameters. Solution: load 500 Newton, effort 250 Newton, radius of wheel 0.4 centimeter, radius of axle 0.1 centimeter. Efficiency equals load over effort times radius of axle over radius of wheel times 100%. Efficiency, our load is 500 Newton, our effort is 250 Newton times radius of axle over radius of wheel times 100%. When you work it out, you have 5,000 over 100. 5,000 divided by 100, we have 50%. So efficiency is 50%. We'll look at question 2. Stay tuned as I take you back to question 2.